to Mr. Ring's website or to his YouTube channel. He will teach you to learn to love math again. Mr. Ring, the #1 math teacher in the whole world.
And number 7 tells us use the factor theorem to determine whether a given expression is a factor of each polynomial. Then explain your answer. Okay, so let's review the factor theorem. This is how I like to abbreviate it. It's a different color. F stands for? It's a factor when?
Zero.
What's 0?
Your remainder.
Your remainder is 0. This is how I summarize a factor theorem. F, the factor, if it is a factor when your remainder is 0 or there is no remainder. Okay? I want to explain this worked out example. Is x minus 2 a factor of f of x equals x cubed plus 8x squared minus 31x plus 22? Well, to transform x minus 2, I'm going to have to set it equal to 0. And then what do I do? You add 2 to both sides, and then we get x equals positive 2. Well, what do I do with this x equals 2? Every x value they're putting in here a positive 2. So they got 2 cubed is 8, 2 squared, which is 4, times 8 is 32, 2 times negative 31 is negative 62, and 22. Add those together, you get 0. Okay, that's our math, the algebraic work, and this is our reasoning, our explanation. And you can literally just copy the sentence. When f of x is evaluated at 2, or when another way of writing it is when x is equal to 2, the result is 0. So by the factor theorem, x minus 2 is a factor. Use the factor theorem to determine whether the given expression is a factor of each polynomial. Question number 2. It says, is x minus 3 a factor of all of this? Now, for right now, the only information you guys know is what we did last week was substituting. If I substitute it in there, I get a number, an output. Okay? We talked about how these, if you notice what we did on last week, these points here, class, do they cross the x-axis? No. So let's see what happens when we do a problem like this. Now, this is a factor, x minus 3. We're asking it's a factor, but x minus 3, and we're going to set it equal to 0. Everyone say set it equal to 0. If I set this equal to 0, x minus 3 equals 0, then how do I solve for x? Add 3. That means is x is equal to 3. Okay, this is a big idea. X minus 3 is the same thing as x equals 3. You can say that again. X minus 3 is the same thing as x equals 3. It's kind of like a hamburger. It's the same thing as a burger. Okay? X equals 3 is the same thing as x minus 3. How do we use that? If I take this value, now I can put it in for every x value. And then we're going to figure out if the answer is equal to 0, then it's a factor. But if I have a remainder or a different number, then it's not a factor. Let's do that together. So f of 3 equals 4 times 3 to the 4th power minus 3 to the 3rd power minus 52 to the 3 squared. And this page kind of ran out of space, so it's a minus 35 to the 3rd power, or not 3rd, but times 3 plus 12. So all I did there was every x value we're putting in as 3. That's what I did. Alright, I'm going to pause here. I'm going to give you and your partner 60 seconds. I want you to simplify the rest, and then I'll call on you guys to help me with the rest. Ready, set, go. Brandon. 4 times 3 to the 4th power. What do we do first? Should I multiply or do exponents? Exponents? What is 3 to the 4th power? 81. Remember, the common mistake here is you could have done 4 times 3 is 12. It is not 12 to the 4th power. Brandon? Should I do negative 3 to the 3rd power? Remember, what do you do first? Exponent. So this is 3 to the 3rd power, which is what? And then you multiply it by negative 1. What do you get? Negative. So you're doing 3 to the 3rd power. And then opposite that, which is negative 27. Julian. What do I do here? Multiply or exponents? Multiply?
No, exponents.
Exponents. Yes, we want to follow the laws of PEMDAS. Someone has created an order that helps us simplify. Julian, here. So? Positive or negative?
Negative.
Noel.
I started it wrong. I did the exponent first.
Okay, multiply for us now. Four times 81. And negative 52 times 9.
Negative 468.
Thank you. Selena? If I add all of those together, what did you get? Raise your hand if you got negative 264. Double check. One, two, three. Whoops. 4 times x to the 4th minus x to the 3rd minus 52x squared minus 35x plus 12. And you're substituting in 3. Did I write it right? Negative x to the 3rd minus 52x squared. Good job, Megan. And we put in 3, negative 264. Alright. Raise your hand if you got that. Good job. Okay, now I want you to draw a sketch, just like we did on last week's lesson. 20 seconds, draw a sketch. Really set, go. Draw a sketch, draw a sketch. Put your finger on the degree. Show your partner. Tell them what that means. Darian, what's the degree? 4 is correct. Is this even or odd? What does that tell us? Okay. Evens do bounce if it was multiplicity. That has to deal with the parentheses and the number on the top. So this is more of an even degree polynomial. Where are the arrows? This is my question. Starts up, ends up. So if I draw something, I don't know, something like that, and then we've been working on x equals 3. This is my intersection. This is an order pair, 3, negative 264. Class, does that cross the x-axis? Yes or no? No. Class, is this number equal to 0?
No.
No. So if it's equal to a different number, it's what?
Not a factor.
Not a factor. So 2 ways to explain to you why the answer is not a factor. It doesn't cross the x-axis, and this number is not equal to 0. Class, who knows my mistake? Yeah. Yeah. Right 3, down negative 264. But it's the same idea. Class, does it cross the x-axis? No. So that's the order pair 3, negative 264.
I love math. You don't love math? What's wrong with you? I love math.
Alright, they asked, is it a factor? The student just wrote 12 above. I think they meant to say that x is equal to 12. They put it into our function here. Got some really large numbers. And they got 0. So they wrote f of x. Oh, evaluated at 12 equals 0. X minus 12 is a factor. I like that. Let's take a look at this one. Whoa, 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 whoa. Is that a 4? Put those in parentheses. 12 to the 4th power. Okay. Do we have an explanation? Are there sentences? No. So I think this one's missing an explanation. I would give it 3 out of 4.
Say yours.
And this one? Working hard. They're working hard, right? Total squares. Well, I'm impressed. They found out that the answer is 0 without a calculator, so they worked hard, but that is correct. Still missing a explanation though, okay? Angie, help us do the substitution. We just set this one equal to 0, got x equals 8. Now we're plugging in what number for x, Angie? Alright, tell me what to write. Negative 8 or positive 8?
Positive 8.
There you go.
Positive 8 minus 7.
Yep.
Parentheses 8 plus 8. Second. Minus 14. Parentheses 8 plus 48.
Raise your hand if you got that so far. Good job. Roll. 8 to the 3rd power. Eight squared. Just 8 squared. Negative 14 times 8. Thank you, Arul. Brian, did you come back? JP? Negative 7 times 64?
448.
Negative 448? And then when you add all of those numbers together, Chris, what do you get? 0. Raise your hand if you got that. Nice. Partner A, tell partner B your statement, your sentence. Ready, set, go. And tell them why. Melissa, tell us the statement. What's 0? This number, right? If you put it up here, what does the R represent? Melissa, what does the R represent? Yeah, because remainder is what? So yes, it is a factor. It is a factor because the what? Because the remainder is 0. And if you do a quick sketch, x is equal to 8 is over here. If I draw a sketch, odd degree polynomial starts down, ends up. I know that it's going to go through the x-axis there. You see the difference now? So if it touches the x-axis, then yes, it's a factor. If your remainder is 0, then it's a factor. Why? Why is that the case? Because, class, what's the order pair there? 8, 0. Your x value is 8 and your y value is 0. Use the factor theorem to determine whether the given expression, so determine is yes or no, whether the expression is a factor of each polynomial. So in question number 5, it says, is x minus 5 a factor of this polynomial? The first thing you're going to do is change this. You're going to set it equal to 0. Set equal to 0. Let's do that. X minus 5 equals 0. Class, to solve for x, you're going to have to do what? Add 5 to both sides. So x is equal to 5. I want to stress this point because it is super important. It's going to help you for the next couple of weeks. X minus 5 is the same thing as x equals 5. X minus 5 is the same thing as x equals 5. Sometimes you'll see x minus 5 in parentheses. Okay? Now the next thing I'm going to do is take this x equals 5 and replace it for every x value. Now I have f of 5 equals 5 to the third power. Notice I'm doing a substitution with parentheses. And then we did this problem back in last week, right? Alright. Angel R. 5 to the third power. Angel, should I do 5 squared or 5 times 5? Which is what? Good. This one becomes? Yep. Angel, or keep going.
It's 125 plus 125 minus that.
And all of that becomes?
140. 240.
Raise your hand if you got 240. So let's draw a sketch. Put your finger on the degree of the polynomial. Show your partner. Give a head nod. Partner A, tell partner B, what does it tell you about the arrows? Ready, set, go. Brendan, what's the degree of the polynomial? Odd or even? Where are the arrows? Correct. If I graph the order pair 5, 240, 5, 240, my graph has to go there. So if I sketch a graph now, and from last week we kind of made a line through x equals 5. Okay, this is Friday's lesson. Class, does it touch the x-axis on the pink line here?
Yeah.
Does it go through the x-axis, the graph?
Oh no.
No, it doesn't. So no, it is not a factor. Alright, let me connect this now to today's lesson. So this was the graph, this was Friday's lesson, and I was kind of noting that if it does cross the x-axis, then it's a factor. Well, in today's lesson, we learned that if you have no remainder, then it is a factor. But if you have a remainder, then no, it's not a factor. So class, do we have a remainder? Yes. Is it going to be a factor? No. Remember, the big idea of the factor theorem is it's a factor if your remainder is 0. So it's not a factor because we have a remainder.
I love math. You don't love math? What's wrong with you? I love math.
In question number 6, tells you to use the factor theorem to determine whether the given expression is a factor of each polynomial. Yesterday we learned that if you set this equal to 0, and I just solved this little problem here. Remember, you're using PEMDAS backwards to solve. So I would not divide by 3. You get x equals negative 4/3. Raise your hand if you got that. Okay, so now I'm going to take that number and I'm going to substitute it in for every x value. So now I put in negative 4/3. And I'm going to go ahead and simplify. Now I did ask if you guys could try to keep them as fractions as long as possible. Now I'm going to use PEMDAS to simplify. So exponents first, 4 to the 3rd power. What does that give me? 64? And then 3 to the 3rd power is 9. this is a negative expression squared. Now, this expression was cubed, right? So negative times negative times negative is still negative. This is going to become a positive. 4 squared is 16, and 3 squared is 9. Oh, 27. Good job, Jasmine. 3 cubed is 27, not 9, not 3 times 3, which is the mistake I made. And then 18, let's just write 18 times negative 4 times 3 plus 8. Okay, so I'm going to show you guys how I simplify my fractions. It looks kind of long, but I think you'll understand why they do things called cross-canceling. So I'm going to write 3 over 1 times negative 64 over 9 times 3. And then 16 I'm going to write as 16 over, I guess that's the same. And then I'm going to write 18 as 6 times 3. Plus 8. And you might be asking, why am I doing all this work with a fraction? Because they have a fraction. They actually didn't give us a decimal. I'm going to cancel my 3's there. So that one becomes negative 64 over 9. That one I'm just going to multiply, so 13 over 1. So I'm just going to multiply across for fractions. 208 over 9. My 3's I'm going to cancel here. So I have 6 times negative 4, which is negative 24, plus 8. For fractions, you just you're going to add the numerators at the top. So 208 minus 64. This gives me 144 over 9. And 24, that will give me negative 16. How do I get a nice fraction? I'm just going to put this one over 1. I'm going to multiply by 9 over 9. The reason why I'm doing this, so I have a common denominator. So 144 over 9. And negative 16 times 9 gives us negative 144 over 9. That's a 4. So I have a positive, I have a negative, that equals 0. So f of negative 4/3 equals 0. Yesterday we learned that if your remainder is 0, then is it a factor?
Yes.
Yes, it is a factor. So there's our statement. And then let's go ahead and draw a quick picture. Super fast sketch just to help us understand what's happening here. I have a odd degree polynomial because it is a power of 3. I gotta zoom way out. So that is a odd degree, so that means that based off of this number here, I'm going to start down and up. To improve on the accuracy of your graph, I have a y-intercept of plus 8. And this green line I'm drawing is telling me where negative x equals negative 4/3. And then the order pair, in fact, zoom back in for you. Negative 4/3 0 is on the screen line. It's actually on the x-axis itself. Super important. And then I can just sketch my points. And there's a quick sketch of my graph. So we had to work with a fraction. Question for those who tried to convert that to negative 1.33 and you put it in. Did it give you 0? Do you know why? Because it's rounding. Negative 1.3 is not good enough. You need negative 1.3 for all of the infinity long, and you still won't get 0 because you're always constantly rounding. Okay? So that's why I had to use fractions.
Math is counting all your friends. 1, 2, 3, 4, 5. It's adding and subtracting. All you have to do is try.
Do math, because math is the best.